In this video, we will discuss how to find the sum of an infinite geometric sequence. We did a few examples like this back in 9.1, so we will revisit this idea. But in 9.1, again, we kind of just felt our way through these things rather than coming up with a concrete way of evaluating these. But now that we're diving specifically into geometric sequences, there's a formula that can be used to find the sum of an infinite number of numbers, which is a beautiful, beautiful idea. When you have a geometric sequence where the absolute value of r is less than 1, that's a really, really, really important feature of this problem. It is super important to identify that the common ratio is less than 1. If the common ratio is greater than 1, the sequence diverges. And no infinite sum exists. You can't actually, not possible. No sum exists of an infinite series like this. But, as I said, if r is less than 1, the absolute value, of course, could be negative, but the absolute value of r is less than 1, the sequence converges. Converges being the opposite of diverges. In other words, it comes together and makes a sum possible. So let's check out how this works. Here's an infinite sequence, an infinite series. This right here, the base of the exponent r is 0.5 or 1/2. Fulfills the idea that they have to be less than 1. So the idea that r is less than 1 is fulfilled, so this infinite sequence is possible, or this infinite series. And so here's how you find it. S sub infinity, a sub 1 over 1 minus r, pretty straightforward. The first term of the sequence, plugging in k equals 1. 2 times 1/2 to the first power is just simply 1. R itself is 1/2 or 0.5. Doesn't really matter which way you write it. But any way you look at it, 1 minus 1/2 is 1/2. And so what this means is this is the sum of all of the members of this sequence, which means that an infinite number of values add up to a finite sum, which is, as we said, a pretty spectacular idea. And that is how you find the sum of an infinite geometric series.